Hello, my name is Dhravid Kumar, and this is my Engage video for the 2017 Film Festival. In this video, I will be showing you how to deassemble and then reassemble a custom PC. This is a custom PC that I built in the past. First, to deassemble it, I must unmount all the cables coming from the PSU. The PSU is the power supply unit. This converts AC electricity that comes from the wall or alternating current to DC, which is direct current, and supplies it in the correct amounts to each component. As I work, I make sure I wear a static electricity band to keep myself grounded, to make sure that I do not damage any of the computer parts with static electricity buildup as I'm working on a carpet. I pull out all the cables from the hard drives and the motherboard and all the other components and route them through the cable management holes as I pull out the PSU. The PSU I am using in my build is a 600 watt Corsair non-modular power supply.
Shutterstock Music.
Now I'm unplugging all of the SATA data connectors. This lets data transfer through a SATA interface to hard drives, SSDs, and optical drives.
Shutterstock Music.
As I unplug these cables from my motherboard, I get ready to unmount the motherboard. SATA cables have two PCIe lanes. That determines the speed in which they can connect to the CPU. The more PCIe lanes, the faster the connection is. Now I start to unmount the fans of the computer. Fans are critical to ensure airflow throughout the case. I have these top two fans that bring cool air in, and I have a fan at the front of the case that brings cool air in. And I have a rear exhaust fan that will make sure all the hot air is blown out. As you add more voltage to computer parts, there's more heat generated. If this heat is not exhausted quickly, your PC will become very hot and crash, and this will not allow for overclocking. Overclocking is just taking the frequency of a CPU or GPU, graphics processing unit, or a central processing unit, and increasing the cycles per second. The fans I am using are case flow fans by Corsair. All my intake fans are red LED fans. Therefore, I know which ones are intake and which ones are exhaust when I deassemble later. Make sure, if you have a very cluttered build, to use static pressure fans, as this will help push air through things like radiators and messy cables. A modular power supply will also make sure you have good cable management. Now, I unmount the rear exhaust fan. This is a blue LED fan, made by Corsair and used for case flow.
Shutterstock Music.
Now, I begin to make sure all of the front I/O cables are unplugged from the motherboard. Now I unmount the memory. I'm using 8 gigs of DDR3 memory clocked at 2400 megahertz. As I unlock all of the PCIe locks, these slots, called PCIe slots, can have up to 16 PCIe lanes. That ensures a very close and fast connection to the CPU. I have 2 cards in PCIe slots, a Wi-Fi card and a graphics card. The graphics card contains VRAM, which is memory used to process large data sets, and it also contains a GPU that processes graphics. It's a graphics processing unit. This is a GT610. That is my Wi-Fi card. As on this motherboard does not have built-in Wi-Fi, I had to put in an external card that allowed me to connect to the internet wirelessly. Now I start unmounting my motherboard. There are 9 screws on my motherboard. Make sure you unmount them all carefully as not to lose them.
Shutterstock Music.
Now I remove the motherboard carefully to make sure that nothing is damaged. Then I remove the I/O shield. This makes sure the I/O on the motherboard is not damaged when you're placing it in. I take the motherboard box out and I put the motherboard on the box as to prevent damage to the PCB or printed circuit board. I unmount the CPU cooler. CPU coolers are necessary to make sure that the CPU runs at cold temperatures for both overclocking and if it runs too hot, your computer will often crash. I'm using a Noctua NHLI, which is a low profile cooler. Now I start to clean off the CPU. The CPU has thermal paste applied to it. Thermal paste is necessary to seal microscopic gaps in between the heatsink and the CPU heat spreader. By doing this, you're ensuring good contact between the two and good heat transfer. You can use nail polish or 99% isopropyl alcohol. Put it on a cotton ball and make sure to rub it off carefully. In this build, my CPU is an Intel Skylake Core i3 processor clocked at 3.2 GHz.
Shutterstock Music.
Make sure to clean the old thermal paste thoroughly, as this can affect if you put new thermal paste, it will not seal the gaps as well. Then, take off the retention arm and pull the CPU out, making sure not to touch the silver part. The pins on the back, you should not touch either. Now I'm putting a Core i7 7700K Kaby Lake processor. The K stands for an overclockable unlocked CPU. This CPU is clocked at 4.2 GHz and boost clock up to 4.5 GHz. As you take out the CPU, make sure to handle only by the sides, the green sides, and align the triangle with the golden triangle on your motherboard socket as to put it in the right place. Then, push down on the retention arm and ensure a snug fit. You will hear a small cracking noise, but that is normal. Make sure it's retained properly and continue on with your build. Next, I put the motherboard back on the box and reapply NTH1 thermal paste. This is Noctua's thermal paste and is very good for stable overclocking. And then you put the CPU cooler back on the CPU. Turn the motherboard around and screw in the mounting screws.
Shutterstock Music.
Make sure to screw them in diagonally from each other as to not over tighten and warp or break your motherboard. I put back the Core i3 and I put in the last of the mounting screws. I make sure that there is a snug contact between the CPU cooler and the CPU, and then put in the final screw, tightening it diagonally. Now I take my old graphics card and I put it back into an anti-static band as I will be installing a new GPU. This is the GTX 1060 from Asus. I insert the memory back in, put them in the two same colored channels after you pull back on the locks and push it, and just push it in hard until you hear a click. Make sure they're in the two channels that are the same color, otherwise you will not be running as quickly as you want your memory to be running. Next, remount your power supply and make sure to stay grounded this entire process. As I screw in the power supply, note that I have one motherboard standoff in. This is to ensure that it's touching the metal of the case and keeping me grounded.
Shutterstock Music.
Motherboard standoffs are used to keep the motherboard from touching the case. That way, there's no short circuiting between the motherboard and the case of the PC.
Shutterstock Music.
Next, I clear the wiring so I can set my motherboard on the 9 standoffs. Once you put them on the 9 standoffs and make sure that the standoffs are in line with the screw the motherboard in, making sure to also go diagonally when tightening. But put in your I/O shield first and make sure that the motherboard I/O is in line with the I/O shield.
Shutterstock Music.
Put the motherboard in properly, and then put in your mounting screws. Right now I'm just making sure everything's undusted because I do not have dust filters in this build. Dust filters make sure that any dust builds up inside the PC and makes it very hard for airflow. They can also damage many components.
Shutterstock Music. Shutterstock Music. Shutterstock Music. Shutterstock Music. Shutterstock Music.
As I put in the final screw, I ensure all of the screws are tightened properly.
Shutterstock Music. Shutterstock Music.
Make sure not to tighten one screw too much, as that will break or warp the motherboard.
Shutterstock Music. Shutterstock Music.
Next, I take out one of the PCIe slots and swap out a motherboard screw.
Shutterstock Music.
and make sure the motherboard is mounted properly and it won't change and move as I tilt it in different directions.
Shutterstock music. Shutterstock music.
Then I plug in the fan connector to the CPU fan connector on the motherboard. Now I unbox the new graphics card, and I have to take out one PCIe slot holder to make sure that I have room for this new 2-slot card compared to my old 1-slot card.
Shutterstock music.
You just pull out this card, put the new card in as you unlock the PCIe lock, and then screw in, and then the lock will automatically click into place, and then screw in the 2 mounting brackets on the side of the computer. Put back the Wi-Fi card,
Shutterstock music.
and screw in that screw as well.
Shutterstock music.
For this graphics card, I will need an extra 6-pin connector, as the PCIe slot can't provide enough power to power this card alone. It needs a separate cable from the PSU.
Shutterstock music. Shutterstock music. Shutterstock music. Shutterstock music.
As I make sure the optical drive and hard drive are now secure before I plug in the power cables to them. Then I arrange the motherboard 24-pin connector to make sure I'm ready to plug that in to power the motherboard. I plug in the CPU power connector, which is an 8-pin power connector that separately delivers power to the CPU. This CPU will require 95 watts and cannot be powered just by the board. Then I plug in the 24-pin motherboard connector and get ready to plug in the hard drive cables.
Shutterstock music. Shutterstock music. Shutterstock Music. Shutterstock Music. Shutterstock Music.
Now I plug in the front I/O cables. These cables are controlling the front I/O, and make sure you can plug in USBs to the front of the case, and your power button on the front of the case also works. Make sure to put these in the correct polarity, as if the negative goes to the positive and the positive goes to the negative, your case will have many problems and could possibly be ruined.
Shutterstock Music.
Be very careful when putting these cables in, as this also controls your front headphone jack, and if you mess this up, you'll get lots of electrical interference and get a humming sound if you plug in headphones to the front of your case. A better solution from audio from lower end motherboards is a DAC, or digital to analog converter. These converters can sit outside of your case and will not have as much electrical interference, and they will sound very, very good. All the front I/O cables are very, very small, so it is very hard to show where they go in. They generally go in the bottom of the board, but it changes with every case and motherboard, as the case determines the motherboard's orientation. Make sure you know if your case is USB 2.0, USB 3.0, or USB 3.1, as you have to plug the different types into the different respective cables.
Shutterstock Music. Shutterstock.
I just finished plugging in the front I/O cables, making sure that they're all plugged in correctly, so if I ever need to plug something in, I can plug it into the front rather than the back of the PC. I also make sure to tidy up my cable management, as this is very important for making sure your PC is very cool. I finally begin to label after I make sure everything is put in properly. I label each cable to ensure that if I ever need to trace the cable back, I will be able to do so very easily without having to unplug my entire system. This is very important, especially if you have a very cluttered build. As I remount the fans in the proper pushing and pulling configurations, I complete my build.
Shutterstock Music. 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 Shutterstock Music.
As this completes my
Shutterstock Music.
deassembly and reassembly of a PC, I thank you for watching and hope this video has been of some benefit to you. Thank you.